All right, good afternoon. We are now starting this webinar for when we should use MongoDB and when you should not use MongoDB. My name is Edward Servan-Schreiber. I'm Director of Solution Architecture here at MongoDB. And by the way, given that there are many of you, thank you very much for coming, by the way. I have a colleague named Buzz Machete who will be answering questions that you ask on the chat room. So when you see Buzz Machete answering, that is actually my colleague and MongoDB answering. All right, so let's look at the agenda. I will talk a little bit about what is MongoDB and what MongoDB is for. And I will discuss what MongoDB does very well, and I think interestingly, what MongoDB does not necessarily very well. And then I will also mention what customers do very well with MongoDB and what they do not try to do, often with good reason. And then I will show you, the span or the landscape of use cases that are usually handled very well by MongoDB, and a couple unusual ones, because the strength of MongoDB is that it can handle a very large array of use cases, some of them not necessarily easy to categorize. So I just will want to show you some of these in order to give you a sense of that. And then some more details about how to decide whether you should use MongoDB or not. So what is MongoDB and what is MongoDB for? The purpose of MongoDB is to basically create applications that were never before possible, or essentially so expensive that they might as well be called impossible. And the key attributes that are emphasized here in terms of making them possible is the agility with which you can develop these applications and the scalability that MongoDB offers you when your application actually has success and has to grow very fast. So our ambition really is to be the data store for all systems of engagement. A system of engagement is really an application that connects with a large population of customers or consumers. Now think about the requirements that are usually expected out of a system of engagement. You have very demanding real-time SLAs. You have very diverse and mixed data sets, because usually a system of engagement must include over time an increasing number of sources of data that it must take into account in order to engage even better with its population. Massive concurrency, because if it is successful at engaging with your customers, there will be thousands, tens of thousands, hundreds of thousands, potentially even millions of concurrent users using the application. It must possibly be globally deployed over not only multiple sites, but multiple continents. And we'll show actually one application later in the presentation of a globally deployed application. No downtime is tolerated, and therefore a system of engagement must survive all kinds of naturally occurring failures and still remain operational. It must be able to grow with user needs, which means that if you need to extend your code or extend the capacity of your system, that must be doable in a simple, automated way that requires no downtime. There is, of course, a very high uncertainty in sizing, because when you launch an application, you don't know the success it's going to have, and therefore you want to launch with a small number of resources, because in case it doesn't work, you want to be able to not commit that much money. And on the other hand, you want to be able to grow very quickly if you are successful. But you really don't know ahead of time how many people will use it. So you have scaling requirements. If your user base grows, you must be able to grow your system accordingly, again with no downtime and no code changes. And all of this to deliver a seamless and consistent experience. Our ambition is to be the ideal data store for these systems. Now, if you think of the database world, right, the classic choice of all databases has been, for the past 30 years, relational databases. And what relational databases have provided us that was absolutely phenomenal is an expressive query language in the form of SQL, a very strong consistency data model so that we could always know and predict very well what we were going to read after it was written, and secondary indexing, meaning that you could actually look up your data in multiple ways and not just through the single key with which you actually stored the data. What it did not provide necessarily was the flexibility of data modeling, and it is actually the nemesis of relational databases and data warehouses to actually extend the data model and grow a data model beyond the original requirements. It was not necessarily built for very high scalability. Essentially, relational databases work with a scaling up model, vertical scaling, which essentially translates to get a bigger server. And it was not necessarily meant to be for very high performance. It was meant for great calculations, but on the other hand, if you need to expect hundreds of thousands of users at the same time on a per second basis or millions, that's not necessarily what it's designed for. It is limited by the hardware it runs on. The NoSQL range of databases are meant to be an answer to these limitations. And generally, as NoSQL usually translates to good key value stores, they provide flexibility in data modeling because the value can be pretty much whatever you want. They provide great scalability features, and they provide great performance profiles. However, in our minds, they tend to throw the baby with the bathwater by not providing really a query language in any sense of the word, not really providing a consistency model that is easy to work with. Usually, NoSQL options work on an eventually consistent consistency data model. Meaning, after you've written something, you're not exactly sure when you will be able to read it. And secondary indexing is not integrated in the system. Usually, it means you have to build it yourself. MongoDB intends to merge the relational benefits with the NoSQL benefits and provide you with a solution that is acceptable and desirable with all of these features. Now, on the other hand, what MongoDB is not. Now, it is not an analytical suite. We're not trying to compete with SAS or SPSS. We are not a data warehouse technology. We're not trying to compete with Teradata, Netezza, or Vertica. And it's interesting to explain why. A data warehouse technology essentially is focused on very efficient full table scans. It is not really, so there will be few users, and each user will be doing massive queries, traversing massive amounts of data. On the other hand, for an operational system like MongoDB, we're focused on trying to handle a massive number of concurrent queries, but each query is only expected to traverse a relatively small amount of data. It's a very different profile. We are not a BI tool. We're not trying to compete with Tableau or ClickView. We're not a visualization tool in that sense. We're not a back office transaction processing technology either. That would be what mainframes do. And that's not the technology that you choose for a system of engagement. We're not either the back end for a billing system or general ledger system. That's generally what things like Oracle RAC is built for. And it sort of requires very specific transactional processing that is for these businesses absolutely critical, but not necessarily something that extends to most systems of engagement. And we are not a search engine. So we're not trying to compete with Elasticsearch or Solr. And generally, as a matter of fact, a lot of customers make MongoDB work in conjunction with Elasticsearch or Solr. So where does MongoDB fit with an enterprise IT stack? If you have the infrastructure at the bottom and the applications at the top, there's usually the data layer and the data management tool in the middle, where you would have offline data technologies that include sort of data warehouses. ADW means enterprise data warehouse, and data lakes, usually in the form of some sort of Hadoop cluster. And these are used for massive analysis and traversing of massive amounts of data, but they are rarely used and are not recommended to be used for any sort of operational usage. That is required with online data technologies, which is usually either an OLTP type relational database or MongoDB. So they are meant to work, the offline data and online data are meant to work next to each other, and we certainly make our claim and our positioning to be squarely on the OLTP side. What has changed? I mean, after all, MongoDB is not that old, and what is so different in the world today that makes MongoDB necessary in our minds? Well, obviously, the systems of engagements have multiplied. What has made them multiply is basically mobile phones, where before it was normal for us to actually call a vendor or a company that we are a customer of and interact in that fashion. Now it is, on the other hand, standard to work through a website or a mobile app, which essentially requires an application, some sort of system of engagement to interact with us, and in a much more direct and massive way. Data, of course, has exploded. That's sort of the story we all read about all the time. What is interesting here is that the big of data is actually the least interesting aspect of it. The most interesting aspect of it is the variety of the data. The fact that you must mix structured data with unstructured data, and it must come from varying sources, and you must be able to welcome new data, even though it was never part of the original requirements. That is what is complicated about big data, much more than the big. Social data is part of the new data that we must integrate, because it is now completely expected by customers to actually be able to contribute and generate data on these applications. And from the enterprise side, what is also very striking is that a lot of these deployments are now completely on the cloud. 30 to 40% of our customers, as MongoDB, have deployed their MongoDB cluster on the cloud. And that includes now very large enterprises who benefit from the cloud by no longer having to invest massively in capital costs early on, and allows them to spread the risk all on operational costs. What does MongoDB look like, and what are its strategic advantages from a technical perspective? So it gives you agility and flexibility through its JSON data model. It gives you high availability in the sense that you can withstand all kinds of failures, either from the network or the hardware or the disks or data centers, natural disasters, and the database will remain available. It gives you very high performance and a strong consistency model that is much easier for developers to work with, and horizontal scalability. What that means is, instead of getting a bigger server to get more performance, you actually have to, you can actually leverage commodity servers to scale your the performance and capacity of your deployment. What is this data model that is making a difference in our minds? Well, think of trying to manage a customer database and the products that they own. In this case, we can think of a car dealer and, say in this case, luxurious car dealer, and the cars that trying to manage which cars are owned by whom. If you were to manage this in a relational setting, you would obviously have at the very least 2 tables, one table for people and one table for cars. And then you would have some foreign key that allows you to connect one table to another. And whenever you wanted to add or look up something, you would have to actually have a join between the 2 tables in order to capture all of the information that is relevant about this particular customer and the cars that he owns. The benefit of MongoDB is to be able to represent data in JSON format, which allows you to have a very flexible, rich structure as on the right, where you can have as many keys and values as you want, and you can extend them over time. It doesn't need to be pre-specified. And you can specify things like a location and then have a geospatial index on it. You can also have arrays so that you can have an array of cars in there that you can extend. You don't need to specify what structure it will have or how many entries it will contain. And each entry can be a subdocument to allow you to organize different aspects and different attributes in each value, so that it would be possible, for example, to have as an entry a truck that would perhaps have very different attributes to describe than a car, and that would also all be okay. So you can see that you still need a schema in order to make any sense of this. The idea is not to transform data into a boneless chicken, but to actually give a backbone to your data without specifying all the details beyond the backbone, so that you can easily extend it with things that are hard to plan ahead of time, as is typical with systems of engagement. In terms of the querying capacity, so MongoDB does not work with SQL, but it works with our own query language, the MongoDB query language, that allows you to actually query in very rich ways. So you can find, in this example, all of Paul's cars, or find everybody in London with a car built between the 1970 and 1980. You can use geospatial indexing that allows you to find all the car owners within a few kilometers of Trafalgar Square. Although since I'm French, perhaps I would only look at Piccadilly Circus and not Trafalgar. We can also use a text search index in case there is a description of the cars or a small text description, so that we can actually have queries based on that text without any further complexity. There is an aggregation framework that allows you to actually have what you would expect from a database, queries such as average group bys or sum group bys, and limited to some subset of the data. So what you would reasonably expect in order to make basic aggregates and get intelligence out of your data. And there is also a MapReduce framework in order to be able to do more complex, mathematically sophisticated aggregations. The requirements that are necessary to really fulfill these challenges is you need to have much more flexible data types, right? You need hierarchical data structures in order to be able to represent data with the flexibility that allows you to grow organically here. You need dynamic schemas. You need to be able to work within the object-oriented programming languages that are used everywhere. You need to be able to scale to hundreds of terabytes or petabytes if necessary, even though you may start only with a few gigabytes and you don't know ahead of time how much volume is going to be necessary over time. You need very high performance. You may start only with a few hundred queries per second, and you may grow to millions of queries per second. You must have controlled cost in order to be able to do this, and we have very strong values based on open source. And you need data consistency. Developers do not enjoy working with an eventually consistent system because it is generally very hard to predict its behavior. Essentially, data consistency debate here means that when data is written, you have to be able to read it back immediately. You need rich querying in order to build the aggregations and the intelligence out of your data that is expected by everyone at this point. And of course, just to make it simpler, we need to have ease of use. How do databases stack up according to these requirements? If we categorize databases in terms of relational databases, key value stores, wide column, which is sort of the big table category of databases, and MongoDB, we feel pretty unashamedly that it stacks up in the following way. Now, generally, the top layer here is where you get the value of NoSQL. It's for the flexibility of data and integration with programming languages, control of cost, performance and scale, and data consistency that people step away from relational databases and choose to adopt a NoSQL technology. What you get for going to MongoDB specifically is really you get the ease of use and rich querying on top of all the other benefits. So as a database, where does MongoDB shine? What MongoDB does well is, first of all, a straightforward replication. Our fundamental unit of deployment is a replica set, and it means that you would have a primary, and it replicates its data to all the secondaries, to all the other replicas in the replica set. What is important here is the straightforward aspect. It's not MongoDB that invented data replication. However, we really do believe that the simplicity with which we can set up a replica set is what makes MongoDB unique here. Something else is high performance on very mixed workloads of reads, writes, and updates. It is possible to have extreme performance on with other databases on purely reads or purely writes or updates. But in the end, what people want is, what we find the market wants is the possibility to use one technology in all kinds of situations, which means that you're not able to specify ahead of time the landscape of usage and the landscape of workloads that you will need, and which is why being able to work on a large profile of mixed workloads is important. Scaling on demand. We're not the first database that scales, but what is important here is the idea of being able to scale when you need it. So you can start, our scaling answer is really to shard out. And you can start with few shards and add shards over time without changing your code. This is the key point. This is not a manual sharding mechanism. So you can add shards, and it will automatically redistribute data, and none of this requires code changes. That is the fundamental point that makes it simple and usable. Location-based deployments, allowing you to have globally deployed clusters that are coherent and functioning as a single cluster. Geospatial queries. Increasingly, the applications that are appearing in the market depend on geospatial location services. High availability and automated failover. What is important here in this system is that when there is a failure, the larger and the more distributed the system is, a failure should have no impact and require no human intervention to recover from. So the important point here is the fact that this fails over in a completely automated sense. No need to wake up at 3 a.m. This is how it translates. A flexible schema that still provides secondary indexing, which means that yes, you can have flexibility in the data, but you can still look up your data in multiple ways. Because if you do not have secondary indexing, that basically means you have only one way to look it up, and I can only imagine what that means when you're trying to look up a customer. If he doesn't know his customer ID, what are you going to do? Agile development with most programming languages. That's through the drivers we have with most all the common programming languages. Working with commodity infrastructures, including cloud infrastructure. Being able to use real-time analytics through our aggregation framework, text indexing, data consistency, and compression. What MongoDB does not do as well is, for example, resource management, which means that if you have multi-tenant systems, it's not necessarily trivial to separate how much how much any particular tenant should own in terms of RAM and cores. Collection scanning under load, which is much more a data warehouse workload. Absolute write availability. This is usually a benefit of the big table class of databases, meaning that if you cannot tolerate even a couple seconds of downtime meaning an inability to write, that usually requires a more specialized database. Faceted search, which is more something that is meant, that is the core use case of search engines. Joins across collections. This is something that is very difficult for distributed systems if you want to maintain performance, and our answer to that is through the flexible data schema that usually mitigates the needs for joins. If you need SQL, SQL is meant for relational databases, and this is a different kind. And transactions over multiple docs. If you want to, usually the transactions over multiple docs are necessary or more necessary when you have a normalized data schema that you would expect in a relational database, and less necessary when your data is denormalized as it usually is in MongoDB. In terms of compression, by the way, this is now, it did not used to be available in MongoDB, but now it is available with our new version 3.0 that came out in February. And by the way, in resource management, the way people mitigate this issue is actually you can do it at the infrastructure level, essentially by using either virtual machines or containers in order to allocate resources to various tenants. What else is there to comment here that is worthwhile? In terms of SQL, by the way, there are now solutions that are being built on the market with ODBC drivers in order to essentially interpret the data in MongoDB as relational data, so that all kinds of technologies above the database that expect tabular structures would be able to work with it. It is not perfect yet, but it is certainly improving quickly. So, and we see customers using BI tools on top of MongoDB through these ODBC drivers. What do people do with MongoDB? That's a useful question. So what people do is, the first thing people do, a very common thing, is single view of whatever you need. So which is single view of the customer, or single view of the product, or single view of the patient, single view of the device, single view of the vehicle. And what usually this means is that the amount of data, the data related to this entity that you care about is usually spread into multiple systems for different uses. And at some point somewhere, usually at the level of the system of engagement, you need to assemble all of the data related to this entity. And you need a data store that is able to assemble all of this information in one place. And MongoDB is ideal for that precisely because of the flexibility of its data model that allows you to assemble all of the data coming from multiple sources and add more data later on. That's the key point. It's not like the decisions you make when you start are rigid and immutable. You can actually extend it very easily as your needs grow. Internet of Things. As we know, all kinds of devices are being spread now everywhere, connected to the internet and sending data. And where do you accumulate this data, and then how do you look into it? Usually, Internet of Things has two needs. One is to just store the data for massive, slow analyses that are more batchy, but then you need a real-time analysis layer in order to be able to react quickly. Enernoc, for example, is an electric utility company, and the smart meters are sending data to a MongoDB system. What this system is doing is analyzing where the current demand for electricity is, and the immediate action that is based on this information is how to route electricity. They want to route electricity where the current demand is, the demand right now, because if you route it in the wrong place, it just goes back in the ground. So this is optimizing the yield, which is very impactful to the business. Enabling mobile apps, famously Foursquare, is essentially all based on MongoDB. Real-time analytics, very similar to what I explained on Enernoc, but McAfee, for example, also does it for cyber threats. A catalog is essentially a single view of the product, and Carfax accumulates all of the data relative to the cars that they track. Under Armour for their product, and Otto, which is the largest catalog retailer in Europe. It owns many brands, and in the U.S. it actually owns Crate and Barrel. So this is actually a very large company, and all of their e-commerce systems are now based on MongoDB, in particular for the product catalog. Personalization. So this is in order to make the experience unique to your users on whatever channel of communication they have. For Expedia, famously, is whenever you search for a particular travel package, the system that functions on MongoDB is the one that evaluates what good deal could you get by changing one aspect of your search, either the departure date or the return date, or allowing one change in your search criteria that would actually make you save some money. And content management, which is usually you have massive amounts of content, and it's how to search and navigate this content, which is usually the metadata about the content. And the metadata requires a lot of flexibility because it's as you add content of different forms, you need very different attributes. So the use cases where MongoDB shines, the single view of anything, Internet of Things, where how do you manage the data from sensor data, the geospatial information and geospatial representation and indexing used through mobile apps, real-time analytics, a catalog, personalization, content management, inventory management, right, where you're trying to understand how much of this product do I actually have available? Can I actually sell it? Should I replenish right now? Personalization engines, a shopping cart system, dependent data marts. That's when you want to essentially share your data with another group and you just need to replicate it but keep it up to date. How do you maintain that? Archiving for very fast lookup. This is usually for compliance requirements where you want to be able to send the data very easily, change it, never have to do a schema migration, but you still want to be able to query very efficiently when you are audited. Collaboration tools, messaging applications, log file aggregations, caching, ad serving. It's actually a very large list, and it's hard to just put a few labels. But where MongoDB is not so good is if you're trying to use it purely as a search engine, because that usually means you need an extraordinary number of indices in order to function coherently as a search engine. And that means that, mechanically, if you have a lot of indices, your writes are going to be correspondingly slower. Slicing and dicing of data in unplanned ways, requiring joins and full scans. That is usually what is done in a data warehouse. Nanosecond latency. We function essentially at millisecond latency, but not nanosecond latency. Uptime beyond 5 nines. Beyond 5 nines usually means that you cannot tolerate more than a couple seconds a year of write unavailability. That is, you have, again, specialized solutions for that. And batch processing. So what is interesting and what we're good for here is that, for example, the Internet of Things, it's a mixture of analytics and archiving that is interesting here. It's very hard to actually be able to do both effectively. In the real-time analytics is you're building information from data as it comes in, right? You will want to actually do batch analysis on this, but you want to have a real-time dashboard of the information that's coming in. Dependent data marts is when you're trying to extract from data warehouses for fast analysis. It's when the marketing department wants to get things from the data warehouse and actually have its own data mart to work with. Archiving for fast lookup, large volumes, targeted queries. Collaboration tool is when you're sharing in near real time. You can tolerate a couple seconds of latencies, but not more. Messaging applications, Twitter-like apps. We even have a framework to build those things because there has been so much demand and expectation on it, and it works very well. Log file aggregation, whether you know it or not, Splunk actually uses MongoDB as in the back end. And caching, enabling massive reads on consolidated data, where you can leverage the performance of MongoDB by getting your data set all in RAM. So for search engine, we only have text indexing for elementary uses, but for larger, broader uses, search engine technology is required for that. If you have unplanned ways of analyzing data, that's a classic data warehouse usage. And it's MongoDB, in order to do good slicing and dicing, needs to actually know how to index the data properly for that. At nanosecond latency, you actually have specialty databases such as KDB built for this. MongoDB needs a few seconds to fail over. So if you cannot tolerate more than a few seconds a year, that means that that is a specialized use case in our book. And batch processing, that tends to be what Hadoop is for. I want to point out something that is a common misconception. Transaction processing does not require database transactions. This is an overloaded term, right? If you're trying to move money from account A to account B, that's never instantaneous and actually requires processing, and it's usually done in batch. It is not done through a database transaction. It could not actually be done at all through a database transaction because usually account A and account B are not in the same system. So let's think about an interesting data consolidation, right? This is a case of an investment bank that does a reference data application. So essentially, reference data is all of these entities that you trade about or that you actually transact with. You want to know everything there that is useful to know about them. Their official name, where they are referenced, what is their current price, where do they close, on which markets they are. And this changes frequently enough that it has to be very actively managed. So in the case of this investment bank, the way this was done before is that there would be a MySQL database built with all the changes in New York, and then you would have separate batch processes replicating the data in New York to all kinds of locations across the world so that traders in each location could actually look up the data locally when they worked. And this was particularly expensive and difficult to handle because each line on this graphic essentially could break independently. And usually it required 36 hours to actually be able to guarantee the arrival of the data. By changing this to MongoDB, where essentially now it is a sharded system, and each shard is a replica set where the replicas are spanning the entire globe, essentially by making the changes in New York, MongoDB is handling the replication across the planet. And it basically means that in a few seconds, whatever change was written in New York is replicated instantly everywhere with no extra licenses, no extra technology, and completely integrated into the system. By making the system so much simpler, not only for the replication aspect, but also for the fact that you could represent reference data very naturally in JSON and extend reference data very easily in JSON. They were able to save, and this is their number, $40 million over 5 years. The reason it's mentioning penalties here is because if it was not getting to each location in time, there were actual penalties. And because some of these locations were getting sufficiently desperate, they were getting extra subscriptions to the data locally because they did not trust the system before. Some unusual cases, which I think are useful just to give a largest sense of the span of usage. It's using MongoDB as a database for molecular similarity. So here you're storing chemical compounds, and chemists have basically come up with the fingerprint representation of and the smiles to basically represent a particular compound. And what you're trying to do is establish, well, how close, how similar is this compound to another? And that's usually established through what's called the Tanimoto coefficient, where the formula is here. And you want to make a query such as, give me all the compounds that have a Tanimoto coefficient of 0.9 or better with this particular system. And that essentially means that you want to be able to look at your compound and through secondary indexing compare them to all the ones that actually have a sufficiently close or a matching fingerprint in a sense. And the number of matching fingerprints is what establishes the N's and the NABs. The NAB is essentially the number of intersecting fingerprints between the two compounds. And this, to compute the Tanimoto coefficient, is essentially a simple aggregation query that allows you to have a very efficient database and a very flexible representation to make this happen. Another one was for big data genomics, where you would have a very large database of DNA sample sequences, and all the metadata around them, where it was collected and the origin, on what date, and things like this. With in the data model also an enumeration of all the possible mutations relative to the reference sequence. What position, what mutation type, and on what base, etc. And you want to retrieve efficiently all the sequences showing a particular mutation. Well, again, by having, this is essentially similar to a content management system where you can have an array of tags in the sequence document with all the mutation names. You can index this array and make queries looking for all the affected sequences that have a particular mutation in that array. This is very easy to set up, very flexible representation, very easy to extend, and can scale to massive volumes. And we know that some drug research companies are using MongoDB in this fashion. A fourth and last case is basically a large industrial vehicle manufacturer. And here what they're doing is, we're talking about tractors basically. And in the tractors, there are lots of sensors. And the sensors are reporting what the tractor is doing and where the tractor is. And here, all this data is going to a central repository, and the operator of the tractors does not even need to be on the tractors anymore. There could be 20 of these tractors functioning at the same time, and essentially the operator is controlling them through an iPad because he sees in real time on the iPad what each tractor is doing and where they are, and whether they are where they should be. And it allows them to catch obvious things like, oh my God, this tractor is sowing wheat when it should be sowing corn. And before it would take obviously an entire season to notice such a thing, and now you can actually correct it in real time. So to answer the question, what database do you need for your business? My answer is that it's the wrong question. It's like asking, what vehicle do you want for a race? Unless you tell me what race and what are the constraints of the race, I can't answer you. Are you going to need a truck, a Formula One car, a train, a helicopter, a plane, a motorcycle, a desert riding car? I can answer you what kind of vehicle will be able to handle, a lot of races, and what is going to be extremely specialized vehicles for very specific races, but I cannot answer the question in general. The real question that you should be asking yourself is, what are you trying to achieve? And how we can contribute to this is that MongoDB is not designed for niche use cases. MongoDB strives to be excellent in a very broad range of use cases. So we'll never try to claim that we answer everything, but we will claim that we answer a very wide swath of applications. And our claim is that we are the most balanced database for enterprise applications and performance. Here's perhaps the list you were waiting for from this webinar. Why should you use MongoDB? If you want very high performance, defined as thousands to millions of queries per second with a mix of reads and writes, if you need flexible schema, rich querying with any number of secondary indexes, if you need for replications across multiple data centers and even globally distributed and deployed, if you need to deploy rapidly and scale on demand, you want very great simplicity and ease of deployment to get started, and you need to be able to grow as your success grows. If you need 5 nines of availability, if you need real-time analysis in the database under load, if you need geospatial querying, if you need processing in real time but not in batch, and not just in batch, if you need to promote agile coding methodologies, if you need to deploy over commodity computing and storage architectures, if you want point-in-time recovery, if you need strong data consistency, and if you need advanced security, then my son, yours is this earth and everything that comes with it. Just kidding, that was Rudyard Kipling. But if you need 3 or more, if 3 or more of these apply to you, then really I urge you to try out MongoDB. From a business perspective, if you want management tooling and services, we can provide that with Operations Manager and MMS if you're functioning all on the cloud. If you are focused on the ease of hiring, we have the largest community that makes MongoDB skills much easier to find in the market. If you need a commercial license, if you want to make sure that you have easy adoption for your developers, if you want to be globally supported on all continents, if you need global professional services to help you out, if you need a strong IT ecosystem to integrate with the rest of the other technologies that you're functioning with, if you want to work with a company that is well-funded and insured to live through the next development of the IT world, and if you want to work with the de facto standard for the next generation database, then basically if 2 or more of these are relevant to you, then you should really consider MongoDB. Summary, MongoDB is for systems of engagement. It complements search engines, Hadoop data lakes, and data warehouses. It does not replace these technologies. It works with them. We work with a very wide range of use cases, and that's really the core point. We cannot define the niche of use cases we work with. We work over a very wide horizon. We are recognized by Gartner and Forrester as a leader in the space, and we are the de facto standard for the next generation of databases. And we can provide you with enterprise maturity and integration in the ecosystem that you have already built. We can help with our MongoDB Enterprise Advanced build, the MongoDB Management Service that allows you to run all in the cloud, production support, development support to get you started and get your developers to develop in a much more robust and efficient way if they're starting with MongoDB. We can help you with consulting in order to accelerate and mitigate the risks to your deployment. And we can help you with training. Thank you so much for your attention. And I will ask my dear colleague Buzz to see if there are any questions I should be answering live. So systems of engagements versus system of record. So as a system, it is very common to basically start using MongoDB as a system of engagement and to have the system of record in the back. And then as the comfort level with MongoDB grows, to essentially get rid of the system of record and make the system of engagement become the system of record. Now, that is one possible use case. On the other hand, there are other use cases. For example, if you have a single view of the customer, it is very common for all the sources that provide data to the single view of the customer to all be different systems of records. And that's not going to change. That is really in the structure of the architectural choices that were made. So the way that this is handled is that essentially the system of engagement reads from the single view of the customer MongoDB system, and then the writes and changes to the data are accumulated in MongoDB, and MongoDB then dispatches them to the various system of records so that it can go through all the system of record logic. So there are various patterns to work with system of records. Either eventually MongoDB subsumes the system of record, or it essentially orchestrates with them the change in the data. Other questions? It is, yes. The support for big decimal is on the roadmap. Unfortunately, in this forum, I cannot give you a precise timeline for when it will be delivered. But we definitely do recognize the need for it. Okay. So MongoDB Community versus MongoDB Enterprise Advanced. So essentially, MongoDB Community is what you are able to download right now from the MongoDB site, and essentially that is the core database, and you can work with it, and some people actually deploy with it. The MongoDB Enterprise Advanced build is a different build, and it includes specific features that are usually relevant for an enterprise taking a mission-critical application in production, such as advanced security and external authentication mechanisms. It also includes special auditing features to make sure that there is no tampering allowed and things like this, and better tracking of who is doing what on the database. There are also in the Enterprise Advanced build, you have included SSL to ensure encryption in flight. But as a commercial offering, what an enterprise subscription offers you beyond the Enterprise Advanced build, it offers you access also to Ops Manager, which allows you to monitor and to have monitoring of the database, to have automated maintenance operations on the database, and to have backup and just-in-time restore of the database on-premise. So for customers that basically require the management of the cluster to be on-premise, it is only something that is available through the product called Ops Manager, which is available through an enterprise subscription. Of course, an enterprise subscription also offers you production support and access to our consultants to help you out. And it looks like this is kind of it. thank you so much for your attendance. And encrypted data storage. Good question. Thank you for that last question. So two answers. There's right now and the very near future roadmap. Right now, essentially our answer for encryption at rest is file system encryption mechanisms. So it's something that has to happen outside of the database, and usually customers do this by having file system encryption technology, or key management systems that basically manage the file encryption system. In the future, we intend to include encryption at rest as part of the database, and which means that you will not need to have a separate technology to have encryption at rest on your deployment, which will make things easier for those of you who have HIPAA compliance requirements. Okay, thank you so much for attending. I hope this was useful, and on that note, I bid you farewell and good luck.